And today's just going to be our first day of USACO Bronze, and I believe it's going to be for 10 weeks, every Saturdays from about 5 to 7:30 p.m. It used to be 3:45, starting to 3:45, but we should kind of change. So, just to start off, just be kind of going over what we'll be covering today. So, basically we're going to kind of start off covering a bit about like coding environments, like what sort of things you want to start with to code, right? Like maybe you guys might have heard of IDEs. You guys might have also heard of like the command line. These are both ways to kind of code on. So it's like put something that you use to write your code and turn it into USACO, and kind of just talk a little bit about what USACO is. What kind of the basics. And then I don't know about you guys if you guys really need a review, but assuming you guys already have a bit of CS knowledge, I can maybe go over these things a bit more faster. But some of you guys might have came in with less like CS knowledge than others, and that's fine. So we'll just have these things to kind of refresh you on maybe past CS concepts that you guys might have learned but you guys kind of forgot, and then some example problems that if we have the time we can kind of give to you. It kind of depends on what our background is. So I'll just kind of introduce a little bit about myself. So I'm Patrick. Just call me Patrick. There's really nothing special to my name. And I'm a senior at Monte Vista High School. And some facts about me. Well, one, I really like beef noodle soup, and I also kind of like to eat seaweed, which is kind of like, it's kind of childish, right? You kind of see these people ripping apart like seaweed packs, and I'm still that sort of person who kind of does that. Never broken a bone. Had a lot of scarring. I've kind of fallen off I think a small cliff, like off like Linda Vista. Not sure if you guys know that place. There's like a park there, and there's like that little hill. There's one time when I was just climbing that, and I was trying to head back down. But then there's that part that's really steep, right? When you go down, it's kind of like really vertical, right? So basically, you kind of just don't want to climb up that thing. So don't really make my mistake. I had like a really big scar here. I think I had like a few gashes over here, but I don't really broken a bone. So I guess I'm lucky. Okay, so back to the main relevant stuff of this course. So I prefer to talk in C++, which basically means that I tend to like to code in C++, and I also like to code in Python. But if you guys, which I'm assuming a lot of you guys or most of you guys do, you guys probably are going to be familiar with Java, right? I'm also fine with that. I know some basic I/O and some syntax of it. There might be some stuff that I might need a bit of refreshing, but mainly in C++ guy. And I've been in USACO Plat since 2017, and I believe all of you guys also have the potential to do so. I look forward to you guys being in that. All right. So just as a little start, first of all, have all of you guys? I don't think all of you guys have put initials on your name, so you guys mind maybe like passing this around and maybe like writing your initials if you guys haven't. So have you done it? Okay. All right. Just sign your first and last name, the first two letters. So initials. All of you guys have signed this sheet, right? So, I guess we can maybe first introduce ourselves, I guess. If you guys, I don't know, do you guys want to do this, or you guys want to just kind of skip it? I mean, I kind of want to know, the two main things I kind of want to know is, have you taken CS before? Like, I just want to know what your level is right now, and like, what's the highest CS course you've taken, because I kind of want to know, like, if you're comfortable with, like, like the basics like if statements and while loops and for loops, because that's kind of what we're going to be doing like all the time. It's not really just going to be like one day we're going to be doing that like over the whole course. And what kind of language do you prefer to use? Do you prefer to work with? So that way I kind of just know like if I should be focusing on C++ or Java, because I have materials for on both sides and I kind of want to know which one I'm working with. So you guys want to maybe choose yourselves? Like for those of you who probably haven't, choose yourselves.
Sure.
Sure.
My name's Kelly. I go to Los Altos High. I'm a junior.
Nice.
My favorite food is also beef soup. My dad particularly. It's fantastic.
Yeah, of course.
Not particularly for the fun facts part, and I
Yeah.
have taken a CS course before. The highest level I've taken is AP Comp Sci A, because that's the highest they offer at my
Awesome.
school. And I prefer to work in Java.
Nice.
Okay, so my name's Jack. I'm a freshman also at Los Altos High. My favorite food, I don't really have one. I just feel
that's
like I just eat whatever. Fun facts. Again, there's nothing really special. Have I taken CS? I've taken some CS classes outside of school, and the language I prefer to use is typically Java, but I know a bit of Python.
Yeah, we'll mainly be using C++ and Java throughout this course because Python's kind of too slow. Pretty slow.
I'm Sam. I'm in 8th grade. I go to Redwood Middle School. My favorite food is rice. I like to do origami. I've taken one CS course outside of school, and I like to use C++.
Nice. Yeah, I'm also C++.
I'm Brad. I also go to Redwood Middle School now in 8th grade. And, well, I took like a lot of CS classes. Like I did intro to Java and the intermediate one. Yeah, so I learned to do Java.
Cool.
My name is Ninso. I'm a sophomore at Bellarmine. And fun facts, I do swimming, and my favorite food is candy.
Of course.
And
Halloween candy.
I took this class, USACO Bronze, and I usually use C++.
My name's Erica. I'm a freshman at Monte Vista. My favorite food is sushi. I play violin. I have taken a few CS classes. I took bronze and silver somewhere else, but I failed at silver, so I'm going to do some business.
My name's Allison, and I'm also a freshman at Monte Vista. I don't really have a favorite food. I self-studied Python over the summer. The highest CS course is just the one I'm taking right now at Monte Vista. Java and
Which teacher in
Ken.
Oh, nice. Have Kim for stats, AP stats. he's a really interesting teacher.
I'm Henry. I'm a junior at Woodbrook. I don't have a favorite food. I've taken like Java intensive when I was like 5 years old. And then I took APCS last year outside of school. I exclusively work with Java.
So if all you guys have introduced yourself, right? Okay. Yeah, so it seems like most of this class seems to be using Java as I expected. The last time I taught this, I also named code in Java because that's what everyone did, so I won't really change that. Alright. So I think, yeah, we're done with this stuff. Alright, so, I just want to let you guys know that you guys have like 3 options mainly. I'll be mainly using the web ID, and at least for this course, I think it's fine if you guys use this. But in the actual USACO contest, I recommend that you guys use either like a command line and a text editor, which not a lot of people use, or an ID like Eclipse. Eclipse is a really nice one. I don't tend to use an ID, I tend to use the command line, but that's just my personal choice. So, like for what this web ID does is that we'll mainly just be working on like Rebel, which is like this website, and like on the left side you'll have the place where you code, and then on the far left panel you have like a little bar that kind of says like your main code, like main.java, and then you can put some input files, output files, and you can basically just put them send them into the code, and it will run it, and then you'll get some output. You can check with the USACO test cases to see if you're correct or not. Okay, so before we start today, you guys want to join this Google Classroom code, it's already been there for like a couple of years, but you know. Basically in here you can, oh yeah.
Is there Wi-Fi?
There's Wi-Fi, yes, there is Wi-Fi. I can get the, I believe I have the password. Have you ever joined Springlight Wi-Fi? No, that's the phone number. The Wi-Fi is something else. Yeah. So let me just take the Wi-Fi thing so I can just write it. Right, so let me see for the Wi-Fi. Is there only should be Springlight. Springlight, you can choose one of these, 2.45. And basically the password is 982 595 9408. Check if that works. Cool. Yeah. Are you guys all on Wi-Fi, by the way? So I'll write the password for you guys. If you guys haven't connected yet. So before you do that, right? The Wi-Fi password is 982 595 9408. And basically choose either Springlight 2.4 or Springlight 5. It doesn't really matter. Just the frequency they're different. I think. Yeah. So once you guys done that, basically on this like Google Classroom page, you kind of see all the problems that you can probably do. We'll really depend on whether we have time. We'll probably get to them. So let me know if you guys have problems connecting to the Wi-Fi or if you guys are done with it, I guess. You guys finished with? Did you guys all get into Google Classroom yet? Okay. So I'll just move on. If you guys didn't, then let me know. I mean, I can get back to that later. So I don't know if you guys done this before, but you guys can sign up. I don't know. You guys can try signing up for this right now. USACO. So this is basically just to get you. If you haven't done so, I think some of you might have already done this, but if you guys haven't, then you guys can just make a little account at USACO. So basically, this is the account that you use to do your contests, do practice problems, all that stuff. It also kind of just asks you for maybe like some more personal information, just to see like if you're eligible to go into camp. Like if you guys actually like get to sign up. You can see if you guys are in high school. you don't actually set your password, they send you your password, so you guys are kind of like logging into that the first time you use it. You guys finished doing so? Okay. How many of you guys haven't like done this yet? Like you guys are not done, or you guys had some problems when you guys were doing this? Assuming none of you guys, so I'll just move on. So yeah, I mean I'll kind of talk a little bit about some basic information. So basically about like 2,000, 3,000 people take the bronze test each year. It used to be 1,000, 2,000, but it kind of changed. And there's 4 tests, right? You have December, January, February, and the March one's called US Open. And the reason it's called US Open is because it's the hardest contest of the year. Typically in this month, like of the year, they give you the like really problems that they haven't really asked before, like really like problems that kind of stretch like the limits of the curriculum of like the level you're at. So for example, if you were at maybe sober, instead of just asking binary search, they might mix binary search along with some other like complicated concept like dynamic programming, for instance. Something like that, right? And it's pretty convenient. So you get to pick the time you take to take the test. So there, like every time they have a contest, at the front page of USACO, there's going to be a little button that says "Go to the contest page." And once you see that, right, it means that you can basically start the contest at that moment. And it starts, it can last anywhere from Friday all the way to Monday, and you can start the contest anywhere from that time frame. So meaning like anywhere from Friday to Monday, you can basically click that button. And then once you click that button, right, it's gonna start your 4-hour timer that's gonna probably elapse somewhere over here. So even if you were at like maybe like Monday maybe like 11:59 p.m. you can basically still start the contest, which is 4 hours, and it will elapse out of the allowed time range. But the thing is that after this time frame, right, you cannot start the contest anymore. That's when the button disappears, and that's when they basically start processing the results after this last guy ends. So basically, you get to pick the time between anywhere from Friday to Monday. Just make sure you pick a convenient time. Don't do it out like Monday, because chances are you don't know if they're gonna shut it down or not. I would preferably do the contest on like the Saturday or maybe a Sunday, because if you look at the USACO page, there's always like a little range of dates that they do the contests, right? So if you look at the overview, right, these are the range of dates, and I'm saying this is like Friday, so 14th, 15th, 16th, 17th. This is Friday, Saturday, Sunday, Monday. So I would not want to pick this date because it might be kind of risky. So maybe you can do it after school, they might allow you to do it, but I would really prefer doing it either on Saturday or Sunday. So that's why they're always 3 days apart, because they're always from Saturday to Monday. So you guys call it that. And then let's see. Then about like 10 to 30% of people get into sober, but it's more like probably like half of you guys in this class, or probably more, because like the people who take this contest, there's like not really a lot of people in there, so it's easy to kind of get up the ladder. Not like maybe big contests like AME or AMC, where they have like a lot of people and they want to pick only a few people to get up the ladder to maybe like AME or USACO. Okay, so USACO contest, there's typically around 3 to 4 coding problems, but usually I've seen there's usually 3 problems. And most of the times I've seen there's 4 hours, but it kind of varies. Sometimes they might give you less or more time. You just kind of have to see depending on the day, right? But most of the time I would rely on recoding problems at 4 hours. So make sure to calculate your time evenly between the problems. Maybe you might have to spend a bit more time on every problem for instance, or maybe less. And then for USACO, another thing that people commonly, like beginners, they commonly don't really understand why the problem, like once they submit it, it kind of shows that nothing's being printed out. The reason is because they've been printing to the standard input and output. You know, std in, std out. Like if in Java, let's say you're doing system.out.println, or in C++ you're doing cout. That's printing to the system. That's not printing to the file. So in USACO, they want you to print to a file. So they typically have a file, maybe like let's call it cow, because USACO is all about cows. I don't know why. Some of you guys who've probably seen USACO, you probably might know why they do cow. You have an input file called something.in and something.out. And cow.in contains your input data, right? So maybe it might be the height of the cows, for instance. And then cow.out might be maybe, let's say, what's the index of the cow that has the median height, right? So something like that. I'm just making stuff up. But you have to read in from file input and file output. For C++, you have to do if stream and off stream. So instead of cin into like a variable, you want to maybe do fin to a variable. And then maybe you want to do like if stream fin, and then whatever your input file is. So you need to add these 2 extra lines instead of doing the cin. That's for C++, and I'll get to the details later. But basically you have to add 2 extra lines to tell the code that you want to print to a file, not standard output. For Java, you want to do file reader and buffer writer, and instead of instead of like just like system.out.println and like scanner, so you don't want to do that. And also these are faster than scanner, just letting you guys know. So don't print standard input. And also another cool thing about USACO is that once you're done solving a problem, right, you know the results on immediately. Well, not if you're going to get into the next level, but you're going to know how much test cases your problem was able to do, right? So like, if let's say you had problem 1 and you submitted it and you made an upload, right? Once you made an upload, you would have like 10 boxes and it will start showing up maybe 1 was correct, 2 was correct, 3 was correct. So each of these is a test case. So maybe they feed in an input file and then it checks your output files. It checks if it matches the data that's in that is the correct answer. So like in their database, right? And if it's correct, then star comes up. If it's not correct, then you have an X. And you have like time limit exceeded. They have this thing. They have a red box, and it has a T on it. It means that your program ran out of time. It's not because it made an incorrect answer. It's like an incorrect answer would be maybe like, let's say if they wanted 20 and you wrote 10. That's an incorrect answer. Time limit is just because your program didn't print anything. It just ran out of time. And then if you have like maybe let's say a exclamation mark, that means that your program probably ran into some error, like some boundary error or some sort of like some system error, right? So an example of this would be if let's say you had an array and you had an array's out of bounds exception, or if maybe you had some sort of like segmentation fault in C++, for instance. So something like that, like in Java or C++, that would cause the program to just crash. That's when you get an explanation mark. So that's all the data they'll tell you about the code. Whether you know the correct answer or not, you won't know because they don't want to tell you what the correct answer is. You just know if your code was correct, wrong, exceeded time, or crashed. So that's the only data that they show you. So from these things, you can kind of make some deductions from what your code and what you should be fixing. So just from this big panel, you kind of can maybe figure out what's wrong with your code, or maybe what sort of thing you want to fix. Alright, so time. So before we start looking at some basic problems, let's first just look at maybe like a sample problem, like a really simple one, and some C++ and Java code to go along with it. Do you guys have any questions about the last few slides at this point, by the way? Okay. So So basically, yeah, we're just gonna first look at a little prompt, sample prompt. So don't look this up. I made it myself. So you know. So you guys wanna maybe read that a bit? Also, do you guys prefer if I send you the slides? Or like, sure. So, you guys want to maybe write down your email somewhere maybe? I think that would, oh good. Maybe write it down on a, let's see if I have it. Just take a piece of scratch paper. Hold on. Yeah, you could just write it maybe at the back of that sheet. Let's start it around. Put down your emails. That way you can just get it. So you guys don't need to, by the way, you guys don't need to code this. You guys just need to look at it, that's it. So, for you guys who have seen it, do you guys know what to do? You guys just add 1 to each of these numbers, right? So the first number is basically, so this is what a USACO sample prompt might look like, right? The first number is basically the number of cows that you have, right? And then the next 3 lines are basically the heights of the cows in January 1st, 2019. And then basically what you do is you just add 1 to each of these values and you just print out the values. It's pretty straightforward, right? So it's kind of a silly problem, but yeah. So after you guys are done writing the emails, I will just maybe start and have you guys think about what might be in this code, for instance. Well, I'll also share these. This is called 610 to 614 because I taught another session of it, but it's. So here's, this is what the code for that problem would maybe look like, for instance. So, you guys all see it over here? Or Alright, so basically for C++, right, you have, for those of you guys who are familiar with C++, the top statement tells you that you want to, so these are basically includes first of all. The first one, hash include basically means that these are libraries that you want to declare before you start the code, right? So typically in competitive programming, including like USACO, I tend to like using hash include bits /std c++.h, but it's optional if you guys want to do that. That one line basically references all the libraries that you need. So like vector, IOStream, FStream, string, all these libraries that you need are included in this one library. But for the sake of clarity, I just wrote them one by one. So so over here, the first line basically tells you that you want to include the library that allows you to do file input and output, right? So I told you there's like count on and count out, for example. Using namespace std just tells you that we're going to be using the scope of the standard library. We're not going to be using maybe like some other like namespace. We're going to be specifically using standard libraries, which allows us to file input and file output. And then int main. So for you guys who are doing Java, this is kind of exactly the same, right? It's public static void main string on. So you guys have heard that 100 times. Basically, what this is basically the code that your program just runs automatically. You don't have to call it; it just runs it because that's your main code. And in Java, you actually have to do throws out exception, and the reason being is that sometimes if you maybe like if you read in an integer, like you did integer.parseInt, and instead you actually read in a string that's not an integer or maybe like a car, then it will throw out an error. And basically this allows you to handle that exception without the code crashing, right? If you wanted to make this even further, you can write a little catch over here. I'm not sure if you guys are familiar with that. And basically you can system.out.println what sort of error you have. Right? So that way you kind of know that maybe let's say you ran into an error where you read in a wrong character or read a wrong integer. And for Java it's kind of instead of hash include you just do imports, right? So import java.io.star. This is the IO library. It's just the input and output stuff. It's kind of self-explanatory. util kind of covers stuff like maybe like strings or array lists, I think. I'm not exactly sure about that, but it covers the basic utilities that are required to, like the data structures. That's a way to think about it. Oh yeah, and public class heights, right? Make sure one important thing is that the public class, this name has to be the exact same as the name of the file that you're writing in. So if this Java code, you have to write it in heights.java. It won't work otherwise, at least in USACO. So, if you were, let's say, doing public class main, right, then this would be in main.java. And we're not really supplying any arguments, so we don't really have to care about this part. Buffered reader BR is equal to new buffered reader, new file reader, and this is where we specify our file name. It's called heights.main. So what this means is that this basically goes into heights.in. And this goes to heights.out, this output. It's going to be printed out into heights.out. You guys have any questions on what I'm talking so far? Alright. If you guys have any questions, just let me know. Alright, so print writer PW is basically the code that you use to declare the print writer, which is the code that you use to print out your data into the file that you submit to USACO. I don't like the way that USACO makes print writer, new buffered writer, new file writer, but that's just the way that USACO does it, so let's just do this. Honestly, from my experience, you don't really need the next two lines, like buffered writer and print writer. I think it's kind of redundant, but let's just keep it that way because that's the way USACO does it. Because I just want to make sure that like we don't run into like unexpected IO errors. That's kind of really annoying to bug. Okay, so that's for the C++ equivalent of buffered reader and print writer. We got if stream. So if stream, I means input, and then f stream means file stream. So if stream is basically the input file stream. So it's kind of like cin and cout, but instead of cin and cout, I don't know if you guys are familiar with that. Cin basically means should be command line in, like at least that's how I think of it. So cin basically means that you're reading from the system. So cin is system input and cout is system output. But in USACO, we want to use if stream and off stream because we're trying to write into the file and we're trying to output to the file. So OF stream basically means output file stream. So we're trying to write into this heights.out file. And then the first thing we do, right? So we have the task where we want to try to increment all these numbers by 1, and we have 3 numbers. So what's the first thing we do, right? So the first thing we want to do is we want to figure out how many numbers are in here, right? Because USACO, they're kind of nice. They kind of give you, the first line, it kind of tells you how much data points are in the data that they give you. So for instance, if they give you like 4 data points afterwards, they're going to write 4 first. They're going to tell you like how many data points you have. So in here we have 3 cows, and they have heights 1, 8, and 4. So the first thing we need to do is we need to read in the 3 to know how much data points we have. And for that, In C++, it's kind of straightforward. You declare a variable int n. I haven't initialized it, so don't do anything with it first. But we are gonna populate this variable with file input. So we're gonna basically take our heights.in. We're gonna take the first line of heights.in. So heights.in currently is 3184. The first line is 3, so that basically goes into fn, and 3 goes into n, so n now equals 3. So once n equals 3, right, we're gonna do this for loop. Let's do the Java version. It's kind of the same thing. Integer.parse int br.readline. So br is basically our buffer reader. It basically tells us that we have our heights.in file. And when we read line, we're basically reading the entire line of this file. So maybe let's say you have like a lot of white spaces, it'll read the whole thing. But USACO won't give you any white spaces here. So that you'll only read this 3. So br.readline will return a string 3, a 1 character string. It's just 3. And then what integer.parseInt does is that it takes the string and it parses the integer out of it. So you have a string of 3, and then we just get the 3 out of it. So instead of a string 3, it becomes an integer 3. Because that way we know that when we put it into our for loop, we're going to be iterating with the integer. And I hope you guys are familiar with what the for loop is, right? You guys are all familiar with that, right? You guys just iterate from 0 to 3. I is going to be equal to 0 all the way to 3, and you're going to basically take in one line from your input, and then take the file, take one integer from the heights.in, and then you'll basically just take that into hi. So hi is just heights I, that's why I call it hi, and then we'll just output this into file output, and then we'll output hi plus 1. So what f out is right now it's an empty file, it's heights.in. Initially, when it calls offstream, or when it calls buffer print writer, it automatically creates a file called heights.out. It's empty. But once you start f-outing into it, or in Java, right, once you start doing pw.println, which is printwriter.println, you're just going to start printing out some values. So in this case, it will be 295, which basically is 1 by 1. So we read 1, we print 2, read 8, and we print 1 above that. We read 4, and then we print 1 above that. And then we basically send that out to our output funnel. And so you can see that's our answer, 295. So that's kind of a complicated explanation of a really simple code. Yeah, and then endl, another note, endl in C++ basically means that we're going to end the line. So it's kind of like carriage return, but then it also flushes the output. So that way, it kind of complies with what USACO wants. In Java, you just do println. And then at the end, here's very important. In Java, make sure you do pw.close print writer. You have to close your output stream, or else nothing will get printed out. Because you want to tell the code to basically just close that file. We're done. This is all we're writing, and we're just done. So we're just closing that file. In C++, you don't have to do that. So you guys have any questions on this? This should be basic stuff. Up to now. Alright. And also, by the way, if you guys want to try running this code, alright, I'll actually share this with you guys first. If you guys want to run this code, it's on the slide. There's a Ruffle Link, which I did automatically. Let me first put in the emails one by one. After I send these slides to you guys, just let me know if you guys can access it, so that way I know that you guys got it and I didn't really make a typo. let me know if you guys can see the slides, because I shared it with you guys, but I don't know if you guys can access it. Yeah, I think you guys, I can see 4 people in here so far, so that's good. You guys can basically just run that and just let me know how it's going. I only wrote that in Java, by the way, so if you guys are in C++, you guys can just do the same thing, but just replace the, make a new file and just copy down the C++ code on there and run it. It should be the same result. Let me know if you guys have any trouble doing that. So what you'll see is you'll have a little page. Alright. So for heights.out, let me actually delete that. I don't want it to be there. Yes, please. Right. So once you guys run it, basically it compiles it Java C, and then it gives Java C this file, and once it's done, kind of see the results after version 9.5. That's your I'll also maybe make another C++ version. Or just copy down this code. So you guys can also see what this code is. Yeah, question?
I'm your child, so you probably don't have my email.
Do I not have your email? Okay, let me check. What's your email again?
It's actually DHL.
Wait, sorry.
Yeah, I'm not.
Okay. Do you mind if I
I would just tell you.
DH? Let me know if you got it. Got it?
Yeah.
Cool. Alright, so you guys have any questions on these things, or just wondering again? Like, I would probably move on to some basic view stuff if you guys don't have any questions. I guess you guys don't really have any questions, I'll probably just move on. You guys want to have like a break at around, this clock's wrong, but it's right now it's 5:53. You guys want to have a break at like 6:15. That way it's kind of like halfway between, the class starts at 5 o'clock, right? So at around 6:10 maybe. Let's do, yeah, like 6 o'clock maybe. I think it's better, 6 o'clock. That's probably a better time. That way we kind of just get rid of stuff. And also I don't like really tire you with a lot of slides. Alright. So I think you guys probably already know this, but I'll just go over it really quickly. You're like kind of familiar with the stuff, right? Like the data types. Like, you know, what the data types are. So, I mean, you know, in C++, right, you have all these like longs. So basically for int, int's basically around 32-bit long as you go towards like bigger ones. I think there's like a 64-bit version. And then once you go to float, it's also 32-bit, double is 64-bit, and it has like precision in there, right? So basically what float and double are is basically just int and long, but you get extra decimal places. So you get decimal places to represent numbers that int and long can't represent. String is just like character strings, you know, big bunch of characters in a string. That's what it says. It's literally just a word, right? Bool. Here's the thing, right? In C++ it's called bool, but in Java it's called boolean. I don't know why Java decided to call it boolean, but yeah, they're the same thing. They're 1-bit integers, just represent true and false. And you got arrays of them. So that's what we'll mainly be dealing with. Occasionally, I don't know if you guys will have the time to do so, but if you have time, we can also cover structs, which is basically like, it's kind of like a class in C++, but then instead of a class, it's just what C++ uses. I mean, there's also a class in C++, but struct is basically like a class in C++, like an easier way to represent a class in C++. So basically, it can maybe like represent a variable, and it can have multiple attributes. Vectors are resizable arrays. So instead of just arrays, right? When you define arrays, it might be int ARR of like 12 in C++, and in Java it will be int ARR is equal to new, right? You have to get the new keyword into 12, and that just defines how big your array is, right? In vectors and array lists, these are basically containers that allow you to resize it. So instead of having a fixed size of 12, you can make it as big as you want or as small as you want. And then, that's kind of the basic stuff. These are primitive data types. Basically, that means that they're not part of the object class. And then you have integer, double, string, array list. Those are part of the object class. I won't explain really why, but that's just the way it is. And beyond our scope, we might do hash maps and tree maps if you guys want. Basically, what maps and hash maps, what they are is basically they allow you to, they're basically arrays, but instead of numbers, like indices, like maybe in array 12, instead of ARR of 0, we're just calling ARR of maybe 5. A map or a hash map, they allow you to maybe like get a certain maybe like string, and then it returns like the value at that string. So it allows you to index arrays, instead of indexing them with numbers, it allows you to index them with maybe like strings or some other data types. So you don't have to index with numbers. I won't go over that one too much right now. And also, of course, you have to declare an integer before you do stuff. Common stuff. And I mean in C++, you can use an integer without declaring them, like int x, and then just use it, but it will be some really big number or really small number you want to try to declare. Yeah, I mean, initializing that should be simple. You guys probably know that. If you guys have any questions, you guys can ask. Just initialize int x equal 15, string x, stuff. Okay. What is this? One of the most common. Yeah, so just properties about arrays, and again, just basic review. They have fixed size and dimension, right? So you don't want to like be accessing, like declaring an array of size 12 and then trying to access the 13th element, right? Like, and they're also 0 indices, so like, yeah, I mean, at least you need to know that arrays are also 0 indices. So if you have like an int array of 12, don't call array of 12. That's a common mistake. Call array of 11. That's the maximum you can call it to. Because in array of 12, there's 12 values. It starts from 0 and then it goes all the way to 11. So does that make sense? Right? You kind of just, you can't really call the 12th value, the value at index 12 because it's 0 indices. It's 0 indexed. And they have fixed dimensions. So if you have a 2D array, you can declare a 2D array, but don't make it 3D. And USACO has this memory limit, so this is something that you guys probably need to also be aware of, right? They have a maximum memory limit of 256 megabytes. So when you're considering if your program might be a little bit on the edge, know that integers are like 32 bits approximately. And if let's say you have like a 1D array, then the maximum number of elements, like the maximum x dimension you can do to fit this 256 megabyte, you can just do the math, right? 256 megabytes, and then multiply by, divided by how much bits, maybe like 32 bits, and that's basically the amount of. You can do the dimensional analysis, but basically that's how you figure out how much values you can go up to without exceeding this memory limit. And it should be a pretty big number, so you guys don't need to worry about that for now, for bronze at least. But once you get to the higher level, it does become more of a problem. And, integer arrays can only contain integers. That should be obvious. They're 0 indexed. I'm talking about that as well. In Java, you would get an array out of bounds exception, but in C++, it's harder to figure out when you go out of bounds. Sometimes you might go out of bounds, you might not notice it. It will just give you maybe like a big negative number, or something like that, or a big positive number. So, in C++, it's harder to determine whether you actually went out of bounds, but in Java, it's easy to tell. You just have an array out of bounds exception. Alright, so this is basic syntax. Do I need to go over this? like this stuff, I think you guys might already know how to do that. Right, so int array of 100. You can declare an empty array of 100 objects, or you can declare an array with objects already in there in C++. And I mean, this is 100 elements. You can only go up to the 99th index because it's 0 indexed, right? So this is how you set an array. Like array 99 is equal to 19. You populate the 99th element with element 19. And then for Java, you basically do the same thing, but instead of just setting this, you have to declare a new int 100. And basically you have the same thing. You can declare a array, and then you have the curly braces, and you basically put the element in your array. And this is a multi-dimensional array, and in C++ it's also the same way, right? So if you want to declare a multi-dimensional array, right? Here's a catch in Java that you have to do a little bit more than C++. So first you declare int. You have to declare int double curly braces array is equal to new bracket 100 100. And then after that you have I is equal to 0, I is less than 100, I plus plus. So that means you're going to the first dimension. And for every first dimension you have to set this as a new int, because in array I, how it works is array 0 contains a lot of empty. It's just empty. Array 1 is empty. And then you have to first declare a new array of 100 before it recognizes that this is just populated with an array, right? And then after you're done with that, you can start setting your array with array 1 4 is equal to 14, or maybe some other elements. C++ is a little bit more straightforward, but make sure you declare your values before you use it. Okay, if statements. I think this should be pretty obvious. If something, then you do this. If this something is false, then you do this, right? So, you guys have any questions about this stuff before? Oh, and then extended if statements. So this is a little bit. This is something that you could make mistakes on sometimes if you're not careful. Because doing this, if condition A in statement 1, else if, else if, else if, else, this is different than just saying if condition A and then curly and then curly braces. If condition B and then curly braces. If condition C, like without the else, that's different. What this is saying is if condition A is true, then we'll evaluate this. And then independent of whether this is being evaluated, if condition B, evaluate this. And then independent of whether these two are being evaluated, if condition C, evaluate this. These are all independent of each other. But in here, they're all dependent on each other. That's what the else if part does. It means that if condition A is true, we're going to do this part. If it's false, if it's true, we're going to do this part. But then after we're done with this part, we're just jumping straight out. We're not even going to look at any of these others. If this one's false, then we're going to start looking down here. If this is true, but this is false, right? We're going to do this. And once we're done doing this, we're just going down. We're not looking at anything else further. So this is something that you could get stumped on if you're not careful. So you want to know when you're using if and else if. So one example that this might be useful is if you want to check whether a number x falls in a certain range, right? If x is less than 10, do this. If x is between 10 and 20, do this. If x is greater than 20, do this. For loops, you guys probably know them already as well, but I just want to go over the structure again, right? For those of you probably. So for loop, you basically have a for and an initializer. This is the initial state that you start with. And then once you're done with this initializer, it's going to continuously check this condition and it's going to update. And then once you're done updating, it will go back to the initializer and check go back to the condition and it will check if this is true. If this is true, it will keep doing this. If it's not, it will get out of this. So basically what happens is first does this initializer, checks the condition, does these statements, does the update, and then it goes back to the initializer and it does it over and over again, right? So one example, right, is if you have for I is equal to 0, I is less than 10, I plus plus, and basically in this case, right, it basically prints all the numbers from 0 to 10 exclusive. So here's the thing, it's exclusive because I is less than 10. So it will print out all the numbers from 0 all the way to 9, inclusive. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? And this is different, right? If you have a less than or equal sign, then it will just print out every number from 0 to 20 inclusive. Alright, so you guys want to do this? I don't know. Just check if you guys understand this. So just tell me if, you know, what's the output of these values, or these you know, snippets, right? So like if this was in a main, if this was in a main code and this was run within a class, what would it look like? Like this is not the code you paste to your Java code. You actually have to put a public static void main, you know, public class, that stuff. This is just simplifying. So just disclaimer. So just start with task 1. Let's not do task 2 first yet. You can just tell me what the answer is. Have you guys figured out which ones the first one is? You have a question or? Oh, answer?
Do you just shout it out?
Yeah, you can just shout it out. Like, doesn't matter.
First one's A,
Yeah.
second one's B.
Yeah, of course. And then let's write a for loop that, you know, does this and does this. So you want, like, I'll probably just cover this. Actually, no. Yeah, I guess you guys probably know how to do this. It's fine. All right. So you guys are familiar with this, right? Clear with this? Okay. I think this is enough. This one is not really necessary. All right. So this is the interesting part. So you guys are probably gonna start working on the first code that you guys are probably gonna be working on. So just write a piece of code that will create this following output. And let me just tell you, just give you a hint, it will involve 2 for loops. So one of them, I'll just give you a hint right now. So one of them controls the vertical direction and one of them controls the horizontal direction. That's my first loop. And you guys can do it in whatever environment you want. And you guys can do CN and COut or standard system.out.println. You guys don't have to do file and profile output. That's not necessary at this point. Just want to know how you guys do it. Let me know if you guys have any questions, or if I can do something to get you guys started on this. How are you guys doing on this exercise? mean, you kind of know how to do it, right? 0 to 100, and then yeah, I. Wait, does it start from 1? Let me just check. And then J goes from 1 all the way to I. Actually, at the end, you have to make sure that I goes all the way to 100, so that has to be less than or equal to. Wait, let me just check the last line. Does it go all the way to 100? Because I feel like it might go to 99. Yeah, it goes to 99. Just make sure it goes I is less than or equal, and then that way you kind of you're gonna get the full thing. It doesn't really matter because you're just gonna get an extra line that goes with the phone next to it. So I guess so far one person's been able to solve it. Yep. Nice. Yep, that's correct. You should not be starting from 0, you should be starting from 1. Because yeah, you're going from 1 all the way to I, and I goes from 1. I think it's fine. Right now, does it not run? Like you haven't.
Yeah.
You try run maybe doing something like that. This does it not work? Like it just like basically it's not working, right? I guess for now we can just for the sake of time, you want to just start with like Ruffle or something like online ID. Yeah. And then from here you can basically like you can just maybe replace this with on the L document and let this thing that can run that code. Does that help? Maybe for now. Yeah, you got it. Or your code is from line and it goes with cool. But that's what. How are you other people doing on this thing? You guys know what? Probably throw out the solution at 6:15. And after that we can take a break. Yes. I is equal to 1, I is less than 100, J is equal to 1. No, that prints 1 to 100 and it prints 1 to 100 for all the lines. So J actually depends on I, right? Because J is it basically controls the horizontal direction.
Yeah.
And you want to go from 1 to I, right? Because on the first line you're only printing 1 number, but on the second line you're printing 2 numbers, so your J needs to address that appropriately. Right? So the thing that change if J is less than that's what you're doing? If J is less than I, that's what you're doing. So if J is less than yeah. The problem is that your first line you're not going to be printing anything. The second line you're going to be printing 1. Second line you're printing 2, and then all the way up to 1, 2, and then all the way up to the last line you're going to be printing 1 to 99. I believe. It should be J's less than or equal to I. That way you kind of are able to.
So it doesn't have blanks.
Yeah. That's why the blank shows up, because you have that value that doesn't show up. Just let me know if it works or not. I mean, there is obviously alternative solutions. Like your one is a little bit different than how other people did it, but that's fine. you guys want me to show the solution up? Because it seems like most of you guys have been able to get it. Like, do any of you guys mind if I show the solution right now? Okay. So oops, that's not the let me just show the solution to the oh yeah, okay, so here's the solution. Okay, so I wrote this in C++, but it's kind of the same in Java, right? You just change this into import java .io.star and import java.util.star, right? That's the first two lines. And then for this line, you just, instead of using namespace std, you just make it a public class. So public class main, or whatever your file name is, right? And you have public static void main string args brackets. So basically, if your program gives any arguments, and then this part should be the same, except for the CM, right? So how it works, right? I told you there's two loops that control the vertical and the horizontal progression, and as you see in this slide, the first for loop controls the up and down, right? Because it basically corresponds to the row. So this means I is equal to row 1 all the way to row 100. And then after we're done dealing with like all the rows, we're gonna deal with what to write in each column. And for the first column, we only want to write 1, right? And we know that for each column, like let's say this is row 1, row 2, row 3, row 4, row 5, we're only gonna write up to I, right? So I is equal to 1, I is equal to 2, I is equal to 3. We're only gonna write up to 1 starting from 1. I mean up to I. So for here, row 1, we're only gonna write up to 1, so it's 1. We're gonna write up to 2, which is 1, 2. We're gonna write up to 3, 1, 2, 3. So J, what we're doing is we're gonna write from 1 all the way up to I. And that's how we represent it, because it goes from I all the way to less than or equal to I. And then J++ basically means we're gonna keep incrementing until we get to J is less than or equal to, J is greater than I. And then for each J value, we're gonna print it, and we're gonna print a little space between the two values. And then after we're done with that, we're just gonna create a new line. And for Java, the same thing applies. Instead of doing cout, you just do system.out.println j, or no, sorry, no, system.out.print j, and then you do another system.out.print with a little space, and then over here you just do system.out.println without any, parentheses. I mean, without any like quotes, just the two parentheses, and that basically just makes a new line. So is that clear? You guys understand how to do it? Okay. You guys have any questions? And I think it's about we're way over around 6 o'clock, so I guess we can just kind of take a little 10-minute break if you guys want to. We'll be back at around 6:30ish, and after that we'll basically have another hour.
guys' days?
You guys doing anything over the weekend?
Not really, so far.
Wait, where did
Oh, the restrooms. So how you get there is you have a little. By the way, just you know that key next to the door. Hit that and then go to the restroom. There's like a menu and it's like just like on there. That's right. guess it's 6:30ish. You guys want to resume? Okay. So I'm assuming you guys have all done this, right? Okay. So I'm going to talk about this further. I have to what is this movie? You guys want to do this as well? It's a little multiple choice. Just by the way, USACO never asked me about multiple choice. I'm just doing this just to make sure that you guys understand how like these if statement works, right? how these if statement work. So which one of these will be printed? B. Right, so let's check if x is equal to 20, it's less than 20, so it's not this, so yeah, it satisfies this, so yeah, it's gonna be B. Don't be tricked by this one, it doesn't do this until it's done figuring out if this is true, so B is the correct answer. And then I don't think you guys need to do this since you guys already know how to do it. This is really about bounds. I'll just tell you guys what it is. You guys don't need to solve it, right? It's kind of just gonna be a waste of time. So right over here, this is num's I. Should be num's I. I don't know why this is 0. So over here should be num's I. If you look at these, right? This goes from 0 to 4. So it's going to go from 0, 1, 2, 3, 4. And you know this is a 0 index, right? So the first 4 that are going to be printed is going to be 1, 3, 4, 5. But the next one that's printed, since this is C++, right? There's no such thing as out of bounds exception. It will just give you a really big number. So this is what you're going to see when you try this code out in C++. By the way, it's not going to be this number. It's going to be some random big number. I just put one over here just to show you that big number is going to come up. It can be negative. For Java, basically the same thing happens, right? So 0, 1, 2, 3, 4. When your code iterates from 0 to 4, inclusive, it's going to print out the first 4 values, right? But at the end, this is going to be out of bounds. So you're just going to get this. You're going to get 1, 3, 4, 5, and then after another line, your code will just crash, basically. That's what's going to happen. So that should be kind of trivial. You guys have any questions on this? You guys probably don't need to do this. You guys probably know how to do it 2D ways. And yeah, this is basically the correct answers. This is what implementing for loops looks like. This is the thing I showed you. C was trap, B was correct. And then basically, this is what like an extended if statement looks like. You guys can just look at this if you guys want. If you guys need help on that sort of stuff, you guys can just refer to the slides. Alright, I guess we can start on our first USACO problem, I think. So if you guys go to the slide and you guys look at this problem, go to Google Classroom, or go to the slide and there's like this Google Classroom page, and it will basically direct you to this page. You don't need to submit anything. Don't you put comments on here if you have any questions after the class or during the class, but I won't be looking at submitting stuff. So yeah, just go to this page, USACO page, and then basically try out the problem. This is mainly a problem that just checks. It's not going to require any for loops or anything like that. It's mainly just going to be checking the bounds. So your code should effectively just be a series of mins and maxes. I've kind of given you the answer already, but it could be if statements, it could be min maxes. It should be something along the lines of that. So it shouldn't be too involved. It's a bronze problem from 2016. This problem number 1. You guys can maybe have a. Hold on. Actually, no. First, we can talk about it. You guys want to solve it, or you guys want me to talk over a little bit? Because it's our first problem. What do you guys prefer? Maybe we can first have you look at the problem, and then maybe we'll kind of think about how to do it, because I don't think everyone's going to be on the same page. So you guys can just look at the problem first, and don't write any code yet. Just look at it, and then we can discuss how we can solve that problem. any of you guys solved this problem already before? Like in just ever? I just want to make sure I'm not duplicating any problems. Like if you guys have already solved it, I can give you the problem. So have you guys read the problem? Have all you guys read the problem and understand what it's asking for? So I'll just kind of go through a little bit of it, how the general gist of what might be the approach to this problem. So what this problem's asking you, right? It gives you two pastors. They don't have to be connected, but I'm just making them connected just to make it simple, right? So you just have two random pastors. Two random pastors. Pastor A and maybe pastor B, right? And we're trying to find the minimum square area that will enclose these two pastors. So let's assume that it's going to be this, right? And what they give you is they give you these, the bottom leftmost point and the top rightmost point for both of these pastors. Let's check the problem again. Yeah, the lower left corner and the upper right corner. So that would be x1, y1, and x2, y2 for the first pastor, and then you have x1, y1, and x2, y2 for the second pastor. That's what these coordinates are referring to. And basically, you want to find the minimum area of square that, wraps around this. So if you think about wraps around this, first of all, let's think about the side length of the square. What do you think the side length of the square would be determined by? So we know there's x1, y1, x2, y2. Let's just call this x3, y3, just for sake of simplicity, and x4, y4. So what do you think the side length of so first think about this, right? What do you think the side length of the square would be? How do you determine the side length of the square? Do you guys have any thoughts yet? So it has to be square, right? Both sides have to be the same length, and it has to enclose both of the pastors, and it has to be parallel to the sides, right? It has to have sides parallel to the x and y axis. You can't have a square that's transformed because that makes things harder.
Yeah, next.
What if I told you that you wanted to find the two most farthest points on each dimension? Is that gonna help?
Sure.
Yeah. So look over here, you have x1. So for the x, so let's first look at the y, right? You have y4, which is way at the top edge. Then you have y1, which is way at the top edge. So let's think about that, right? Let's say we have a square that just has a size that basically has a side length y4 minus y1. Would that fit these two pastors? Would it be a yes or no? If I had like a square that has this side length, would it fit both of these pastors? course it would be no, right? If you had like, let's just use a different color, right? Blue, of course, yeah, that doesn't work. Well, assuming, this is what it would look like. You just fit B and you barely even fit A. No matter where you place it, it won't work, right? But now let's look at the x-axis. What if so what are the two farthest points in the x-axis? Like x1, x2, x3, x4, right? What are the 2 points that have the greatest distance between them? x1 and x4, right? Now let's assume we don't have the square, right? Let's just take the square off first. So what if we had a square with length x1 and x4? Would it fit over here on these two? Right? It would wrap around these two, right? x1 and x4. And that's basically, and the proof that we can't go any smaller, let's assume we could go smaller, right? If we went smaller, then you would have to compromise some area from either A or B. And that won't work because we can't delete parts from squares, right? So that proves that this is the optimal solution for this problem. Right? Can you guys see it? And that's kind of another reason why drawing a graph for these problems would be really useful, because then you guys can actually see, the problem, and you guys can actually think about it, right? For like if I did told you that you wanted to check the farthest points, you guys can maybe start drawing some squares around and figure out that, if I started removing parts from this square that wraps around, then it won't work. So then this has to be the middle. This has to be the solution, and we can try maybe on y-axis and x-axis. If we made the minimum y, if we made the decided length of the square the difference between the y values or the difference between the x values, what would change and what would be possible, right? If we play around with these things, we would eventually figure out the rule, which we just figured out right now, which is that you want to find the maximum, or you want to find the maximum distance between both the 2 points with the maximum distance on both x and the y-axis, right? It's kind of a mouthful, but you guys probably would understand it, right? So now that we kind of know that this is kind of the general way that we solve this problem, how do you think we do? Should we code this up, right? We have x1, y1, x2, y3, x1, y1, x2, y2, x2, y3, x4, y4. So you kind of want to find the farthest point on both sides, right? First, which would in this case would be x1 on the right side and x1 on the left side. And not sure if you guys are familiar with the function, which is min and max, right? So min of A and B, right? And max of A and B. In maybe in Java, for Java it would be math.min, math.max. And C++ it would just be min or max. But the problem is that it only accepts 2 arguments. So in order to accept 4 arguments, we'd actually have to add we would have to nest 2 mins inside of each other, right? We have to do math.min, 2 values, and then math.min 2 values, and then another parentheses. That's kind of how you get around with this. But since we know that it has to be that the side length of the square has to be the maximum distance, we basically just check the minimum of all of our x values, which we'll just call it min. I'm just gonna write it in shorthand. Min of x1, y1, x2, actually x1, x2, x3, x4. And then over here we would find the maximum of x1, x2, x3, x4. And then we'll just subtract these two, max minus the min. And that's going to be the longest distance between our 2 values in the x dimension. And we do that same thing for the y dimension. And then we figure out which one requires more, right? Which side requires more length. You can think about it that way. and then we just take the max of these two values. Does that make sense? Okay. This one should, you could preferably implement this in one line of code, but I don't recommend you guys do that. But you can just like write everything in one line, just take in everything in an input and then just print out everything. I mean, there's only one value, right? So you take that maximum distance and you just square that, and that will give you your answer. also a quick note for Java people who are using Java. I just wanted to let you guys, just make you guys aware also, that if you guys are reading 4 inputs, don't just do like, don't just read them in like the br.read line and then expect to read only one input. You wanna, do you guys know how to use string tokenizer? So basically, like if you do br.read line, right, from your code, BR is basically a buffer reader, right? So for string tokenizer, you have to declare a string tokenizer, which basically reads this whole line, and then you take these numbers one by using st.next token and then integer.parse int st.next token. So if you guys are like using Java and you guys are using buffer reader and print writer, then just be aware that's what you need to do. And make sure to also print out square dot in and square dot out, because USACO will not accept submissions that print to standard inputs. So don't do system.out.println or scanner dot next in or something like that. That won't work. So let me know if you guys have any questions on your code or just reading within the code or what the prompt asking for, something like that. Yeah, but you're still in CN. I mean, for USACO, you want to do that. But I mean, you're at least there right now. It's also cool that you struck. It's a neat way of representing. Yeah, question. Nice, awesome. So 2 people so far. I mean, yeah, just change it to F in, F out, run out anything, and just let me know if you get full. Let me know if you guys are there or if you guys. I'm writing. Meanwhile, I'm just writing the code for that as well because I lost my old version in Pokemon slides. It shouldn't take too long for you to write considering that. So. If it takes more than like 10 lines, there's a bit of a problem. It should take no more than lines. Oh, and by the way, for those of you who are actually, never mind. How are you guys who are solving the problems right now? Let's go 7. I'll probably put up the solutions. Either if everyone's not or maybe like 7 or 5, I guess maybe. I'm gonna show you guys what it looks like. Unless you guys don't want to dash. Yep. Got it?
How should I submit this?
Oh, should we see it? Let me check it too. Screen. Yep, and then that's fine. Then you just basically save it as a file. So you just save it like oh, you don't need to save it, you just copy paste it into like a folder thing. You just take everything and copy, paste. Maybe like some sort of maybe like notepad or something like that.
I do it like
Yeah, you can do it over. Actually, try to make it like .txt, like the Word has this weird like fancy thing, right? Like Notepad probably works better. It uses plain text, right? Let's see. And all of you guys know how to submit your USACO code, right? You just go onto this page. I mean, this is basically your results. If it's all correct, everything's just a star. You select your language. Don't pick C. C is what it starts with, and none of you guys are using C, right? So scroll down and pick your language. These are the available languages. Choose file. This message. Now just say grading in progress, and these blocks just start coming up. It's also when the heartbeat starts going faster and faster. I mean, if you're in the contest. guess it's around 7:05. You guys mind if I show you guys the solution? Or do you guys still want to work on it? Like, are you guys all like sure how to work on it? Or are you guys, some of you guys kind of, okay. I'll also show you my solution. This is a Java. I wrote it up in time that you guys were writing it. Because I lost my own version. So right, so what we do, right, we first initialize our imports, right? Import java.io.star, import java.util.star. So this is file in and file out, and this takes care of your utilities, right? Like stuff that you need, like arrays and stuff like that, we'll run into that. So no, I named this square.java, and just reiterate the point again. You guys want to make sure that your public class has the same name as the file that you're naming. So like if you name your file square.java, your public class would be square. This is kind of typical public static void main string args. Throws out exception in case that you have some sort of IO problem. Java basically just takes care for you. And then these are the two lines that you basically read from the square dot input and square dot output. So right, you basically take your data from square dot input and then you basically print it out square dot output through this code. And here's the string tokenizer stuff that I mentioned. Maybe you guys did it a different way. You guys just use scanner. That's fine. I think scanner also supports file. I'm not sure, but anyways, with buffered reader, I tend to use string tokenizer. So what this does first is, if you look at the USACO page, there's 6688, right? So the first line over here reads in 6688 as a string. So BR.readLine returns 6688. That's what BR.readLine does. And ST instantiates an object of string tokenizer that contains this. And once you go over here, you're basically parsing int every next token. So the next token for this, for instance, would be 6. And by default, string tokenizer delimits the data by spaces. So if you have spaces, it'll take the first chunk, it'll wait until you get a space. It'll take the next chunk, it'll wait until you get a space. It'll take the third chunk, fourth chunk, so on, until you get a space. So for here, there's 4 chunks, right? There's 3 spaces over here, so there's 4 chunks of data. And basically string tokenizer splits it up so that the first one contains a 6, the second one contains a 6, the third one contains an 8, and the fourth one contains an 8. And of course we know that the first 4 values are our first square, right? x1, y1, x2, y2. And then we have another line, right? So we have to instantiate a new string tokenizer object. So we read another line. And in this case, you would get 1849, right? With 3 spaces. So this would be 1, this would be 4, this would be 8, 4, and 9, right? So that would be the values that we get in x3, y3, x4, y4. And now since we want to find the length of the square, we want to find which side requires a longer, length, right? So what's first of all, let's break it down into this, right? So let's first check the x-axis. How long does the square need to satisfy the x-axis? So we take the maximum. So this is why I said nested, because max does not take 4 arguments. It only takes 2 arguments, but we can make it take 4 arguments by nesting max inside maxes, right? So we have map.max, and then we have x1, x2, x3, x4, and we take the maximum value of the x coordinate. So in this case, in like this demonstration, it would be x1 minus x4, the 2 farthest points. That would be x length. And we do the same thing for the y length, right? We take the maximum of all the y lengths, and we take the minimum of all the y lengths, and we call this y length. And whichever one requires a bigger length, that's going to be the side of our square, right? So if let's say x length is like, at least from this picture, x length was bigger. So let's assume it's x length. So in this case, x length would be our square, and we would get something like this, right? Sorry, this. And then you would just print out the maximum of either of these, and you would square it. You can do math.pow this too. That's also fine. It works either way. And then make sure to close your print writer before you submit the file to USACO. And after you're done with this and you try it out maybe the sample test case, 49, you can basically just submit it over here. And I just did this a few seconds ago, and this should be what you get. And for C++, by the way, for those who are using C++, it's really not really much different, right? You do fn, or whatever input that you call it. Like you do if stream, off stream, all that usual stuff. And then you, instead of string tokenizer, you can actually just do it one by one, right? You can do fn some value, and then fn for a value. So you just do fn x1, x1, x2, y1, x2, y2. You don't need to put spaces. You can just do this big thing. Like this arrow basically just means you're taking the values of fn and you're plugging it into this variable. And then if you have another variable, you can put another one, and it just does it one by one by one. So that's a neat thing about C++. And then for this thing, you do the same thing. You don't need the max. Math is not required in C++. They just do it max as 1, x2, x3, x4, and so forth. And then instead of p.println, you just do f out, and then f out, and you do the max, blah blah blah, and then times max blah blah blah. And then you're done, basically. So, any questions about this problem? Did you guys all successfully submit this problem, just out of curiosity? How many of you guys haven't finished it completely? Like haven't gotten green stuff show up on USACO? Okay, so hopefully you guys are done with this at least, but if you guys haven't been done with this, then you guys can finish this up, and then once you submit it, you should hopefully get all of them correct. Because this problem shouldn't take you too much lines in code. Yeah. Alright, 7:13. Yeah, we can move on to maybe another problem, I think we can. We should still have a bit of time. Do you guys want to go over continuing break statements? I think this should be kind of obvious. I mean, I'll just go over it really quickly, right? I mean, so here's basically just like a tool, right, to kind of help you if you don't want to put too much if statements around everything, checking something, or if you don't want to deal with going through a for loop over and over again without doing anything, right? So continuous is just basically a keyword that just basically says that if it's called, it just skips automatically to the front of the for loop. It doesn't do anything at the back. So for this one, it would basically just print everything, right? Except for the time when I is equal to 2, and in that case, it will just jump to the front and it will resume as I is equal to 3. And when I is equal to 3, it's just going to do this normal again. So for this case, we would basically just get 0, since it's less than 10, right? 0, 1, 2. 0, 1, 3, 4, 5, 6, 7, 8, 9, right? 2 is not going to be there because when it's 2, it just skips automatically to the front. And after that, it will just say another clue, but that's not necessary. Okay. And then break statement. When I is equal to that value, or when you call the break statement, what happens instead of going to the front of the for loop, it goes automatically to the back of the for loop, right at the end of the for loop, or whatever. If this is while, it also goes to the end. So it doesn't have to be a for loop over here. It could be a while loop. It could be a, it could be any sort of loop, any sort of iterative process. And when you call that, it basically just jumps out of the iterative process. So for this case, you you just print 0, 1, and then when it's at 2, right, it just breaks. It doesn't continue printing I, and it just says I'm out with that little smiley face. Right? I mean, there's like new lines on each of these, but I didn't take care of that already. Yeah, so that's basic info to basic review of what continue and break statements are. If you guys want to run it, you guys can run it on your free time. Oh yeah, and functions. So yeah, so like one common example of this, right, is if you're trying to convert a certain value to another value, you don't want to have to like plug in this formula every time. So if let's say you have like int x is equal to, I don't know, 40 degrees Fahrenheit, and then int y is equal to 90 degrees Fahrenheit, you don't want to have to just keep writing xc, for example, Celsius of x is equal to x minus 32 multiplied by 5 over 9, well 5.0 over 9.0. And you guys know the reason why I'm doing 5.0 divided by 9.0, right? Not doing 5 over 9. Because if you did it without the dot zeros, it treats as an integer and it just automatically 5 divided by 9 becomes 0, right? You guys know that 5 divided by 9 is equal to 0 in programming. In math, 5 divided by 9 is some decimal. Like it should be 0.55555. But who cares? Okay, so yeah, so in programming, right, you have to do 5.0 divided by 9.0 is equal to 0.555. So yeah, so basically you do that, and basically my point is if you have like, if you don't have a function, right, you're gonna have to keep doing this over and over again. You're gonna have to write y minus 32 times 5.0 divided by 9.0. That's really annoying. Why don't we just, instead of doing this, right, why don't we just make it like x, why don't we just call xc is equal to maybe like c of maybe like some function, right, x. And then yc is equal to c of y. And basically, where c is probably just a function where we convert, Fahrenheit to Celsius. See, it's much simpler. And instead of actually having to write this over and over again, this stuff that you write over and over again will just become a function, right? So maybe like public, I don't know, c, and then int x, right? Public, and then you have to have the return type, right? So over here, if let's say you were taking a double, then you'd probably want to do maybe like public static double c int. It depends on whether you want it in your, if you want it public or private. I don't think it matters in Java, but it does. I mean, in USACO, but I think it does matter if you're actually coding this, in like the workplace. So right, you would just do return x minus 32 multiplied by 5.0 divided by 9.0, right? That way you would just, you don't have to do this. You don't have to do this over again. You can just write this stuff once and then just call it twice, right? That makes it much easier. And that's one of the primary motivations of using functions. Another primary motivation of using functions is recursion. So you guys probably heard recursion, right? Like Fibonacci sequence, right? You could probably just make this like int. Let's do C++ now. Int fibo, int x, right? Return. Oh, so like first you have your base case, right? If x is equal to 0 or x equals 1, then we just return 1, right? Or else we just return x minus fibo of x minus 1. Hold on, between x equal to 1 and x equals 2, right? X minus 1 plus fibo of x minus 2. So you're basically just taking the last two values and you're adding them up, unless they're the first or the second term. In that case, it would just be 1. So fibo of 3, right, would just be fibo 1 plus fibo 1, and that's fibo 1 plus fibo 2. Yeah, fibo 2 plus fibo 1, and that would just be 2, right? And then you just do it over and over, 1, 2, 3, 5, 8, 13, 21, 34, so forth, right? And that's one case where you use the recursion. But in this case, you'll later figure out that this will be really inefficient because it calls this over and over again, and this has a complexity of O to the n. If you done big O notation yet, because you're basically branching out, right? You're calling these, which call in more fibos, and you can visualize it, right? It branches out into like a exponential factor, and once you use this thing called dynamic programming, it kind of helps you use this down the road, and that's something else to talk about, not now. Anyway, so you kind of get the primary motivation and the applications and functions in USACO, right? So they probably won't ask this specifically, you to do this. You don't really need to do this, I think. So this is a task that previous years they've asked USACO Bronze students at Springlight to do. I don't think it's necessary for you to do it. You guys know how to do this, right? You guys just take the sum and average of each number and put it. So this is just simple printing. Making an output. And over here you can just do the same thing, but write a function to do this. What's the time right now? 7:21. I don't know if you guys have any more like energy to do another problem. Hopefully you guys do have some energy to do another problem. This one kind of has to do with functions, kind of doesn't. The way they pose in the solution, they write it as a function. And I think it's pretty helpful if you write it as a function. So it's called contest timing. And if you look at the slides, it should be this Google Classroom page. This is a pretty old one. It's from 2011 November contest. Most of the time is 11 a.m. at 11. Yeah. Not submitted. Shoot. I think for this problem, you do something. You guys can actually use Springline OJ instead. That works better. So, how this works, I don't know if you guys actually have like access, like if you guys have an account here. But basically what this is basically Springline has their own online judge for problems that don't have that basically aren't like accessible directly on USACO. So you guys kind of have to create another account over here. It's kind of annoying. But if you guys don't want to deal with the hassle of that, I don't think it's that bad. You guys can actually just go back on problem list and contest timing. There's a little test data over here, and you guys can just basically once you downloaded it, you get this little folder. You guys have these inputs and outputs. So I is basically the input. You guys can just rename this ctiming.in and ctiming.out, and you guys can try it. But I suggest you guys still like just make an account here, so it's a bit easier. But it's really up to you. Let me see if I still need my account. I think I still need it. really short. Alright, borrow it by what was that?
Your
Sure. Yeah. It's probably gonna, class is probably gonna end in 4 minutes, but do you want it?
That's fine.
Okay. It should end. I mean, if you want, I can.
I'll just leave it.
Sure. Also, yeah, I mean, yeah. Do you have a question?
oh can you check that?
Check yours. You already did it, right?
I didn't do that.
Yeah, and yeah, 1516. Oh, you also have to take care of the case where, remember there's another case. It's asked if it's, so you have 2 parts of the problem, right? You're first asked if it's, if he spent the she spent the contest, but you also have the second part of the problem that you also need to answer, right? So to do that, you need to check if that's maybe like greater than 0 or 1, right? If it's negative, then you know that you don't, that basically she starts earlier than me or something like that. So if it's greater than 0, then you basically print it out, but if it's not, then. It's so weird. Oh. Who set up this Google Classroom? Let me see. That's really. Okay, so you see, go to problem set. Should be called contest. Wow. Anyways, there's probably some other problems that you can access. I mean, there's other like problems that USACO doesn't have, but I think for this one you're probably gonna have to still stick with like the test data here. Let's see. How might so it's contest. Let me first check actually. Yeah, for this problem, you actually can't go to the what's it called, Springline OJ, because Springline Online Judge doesn't have this problem currently. Anyways, I guess we're kind of running a little bit low on time, but did any of you guys figure out the general gist of the problem? I think you guys are already starting to implement it because it shouldn't be too much, but you guys know like the general gist of it, right? So instead of just dealing with these numbers, right, you can actually think about it because it's really annoying to know like if you have like maybe like hours or a lesson, but then minutes are bigger. It's kind of annoying to just deal with it that way. So it's better if we just represent this, days and hours and minutes, just in terms of minutes, right? Because days, there's about like, if you think about it, every day there's 24 times 60 minutes, right? And each hour there's 60 minutes, and minutes, just that same number of minutes. So just add these up, right? And then you know that they start at November 11th, 2011, so you're given another piece of data, and you know the hours are 11 and the minutes are 11. And you also know that your day is also 11, right? So on November the 11th, right? So given these 3 pieces of data, you can also create another integer that represents the number of minutes of this time point. So it's kind of like the amount of time that started since November 1st, 2011 at 12 a.m. That's kind of what we're using that as kind of a reference point. And we're basically taking these two values with respect to that reference point and we're just subtracting them. Because all we All we care about is not how many minutes it is from November 1st, 2011, but rather how long it took for Bessie to spend in the contest, right? So we just take these two values and subtract them, and if they're greater than, if the value is less than 0, right? If it's negative, for instance, then we know that any times earlier than our starting time, then we just return negative. So the code should be shouldn't be too long, and in fact, USACO represented this. I don't know if you guys mind if I show you guys the solution, right? Yeah, they represent it in terms of a function, right? So it's kind of convenient. So you just basically do total minutes DHM, and this is the number of minutes in some predetermined starting point, and in fact, this starting point is November 1st, 2011 at 12 a.m. I believe, if I'm correct. You guys can correct me on that, but I believe that's the starting point. So that's why we basically that's what this total minutes returns. It's the number of points since that starting point, and we're just looking if it's less than that, then we return -1, or else we just return the difference would be 2. Just written out. So it's kind of just a neat way to use function here. So you guys have any questions? I guess. Last problem of today, I guess. You guys can solve it if you guys want. This is in C, I don't know why they did it, but alright, so let me see the slides real quick. Yeah, so after this basically we just have I think we have like one more problem on this set, and that should be pretty much all. We can do this next week and we can complete it on the second slides, but there's not really any homework in this class. If you want, you can solve this and maybe figure out the answer to it, and maybe we can talk about it next week. But you don't have to do it. We can come next week without having solved anything. But later on, I can maybe give you guys more stuff to practice. And yeah, if you guys want to, you guys can also bring some other topics. Help you guys. So hope you guys enjoyed. Or at least, first class, I guess. Let me know how you do better on helping you guys, I guess.